Welcome back. Today we are going to be looking at factoring quadratics. If we had a trinomial that was 6k squared plus 19k plus 3. Now, this is the easiest method that I can use to factor quadratics, and it works for the simple trinomials, which is when the leading coefficient is just a 1, so it's just like a k squared or an x squared, or the messy trinomials when we have any other number here. And the process is quite simple. What I do is I create a box, and I divide it into two columns. Down that first column, I look for what are the numbers that can multiply to make that leading coefficient of 6. Sometimes there is trial and error. It may not work the first time. So when I think of 6, I'm going to try a 3 and 2. Down the last column, we look at what are the numbers that multiply to make 3. I'm going to try 1 and 3. The next step would be to cross multiply. So I'm going to multiply these two together and do 3 times 3, which is 9. And 2 times 1, which is 2. I'm looking to add these together to make that middle term of 19, but there is no way that 2 and 9 will ever make 19. So what I could try is reversing the 1 and the 3 and turn that into a 3 and a 1. When I cross multiply, I will now have a 6 and a 3, but again, those are never going to make 19. So what we might have to try is what are the other numbers that can make 6? And 6 can come from 6 times 1. When I cross multiply, I'm going to have 6 and 3. Again, those will only make 9, or if I subtract 3, I'll never get to 19. So last but not least, let's try reversing and put this one as a 1 and a 6. Now when I cross multiply, I can see that I am going to end up with 6 times 3, which is 18, and 1 times 1, which is 1. Those will add to a positive 19. Once I've determined that, now I can easily see these are my factors. They pair up horizontally. So when I write it into my equation, I will write, remember these are representing also the variable, so this turns into a 1k or just k with a positive 3. And the other factor bracket will turn into a 6k with a positive 1 paired to it. And that is the solution for that one. Let's go ahead and try another one. If I have 5x squared plus 24x minus 5, once again, let's set up a bracket. Or a box, I should say, divided into two columns. Now, again, down this first column, I'm looking for what multiplies to make 5. There is only one combination that will multiply by 5, and that is 1 times 5. Is it going to matter whether or not I put the 5 on the top and the 1 on the bottom? No, because this is the only possible combination that I can possibly make 5 with. Now, down the other column, same thing. What multiplies to make 5? And again, we can do 5 times 1. In my head, I can see that the order would matter here because I am looking to make 24. So if I had put the 1 on top, when I cross multiply, I would have had 5 times 1 and again 1 times 5, which would not get me there. So I did a little mental math first and saw that if I cross multiply, 5 times 5 is 25 and 1 times 1 is 1. I am trying to get to the middle term of 24. The only way to do that is to do 25 subtract 1. If I need to add a negative to any one of these numbers to form my total, that negative must carry into the number in the second column. Not the first column, only the second column. Now I can see my factor pairs here. I am going to have a 1x or just x with a plus 5. And in the other bracket, we will have 5x with that minus 1. And there is now a factored trinomial.